Greetings, math friends. We are going to look at a piecewise defined function and how we would go about graphing this by hand. One of the first things that I like to do is I like to look at these domain restrictions that we have. So I'm looking from right to left. I'm starting over here, and I want to notice these critical values, and I want to note those in my graph. They're not actually going to be a part of the finished graph, but they are important to note when you're plotting. When I look at my Cartesian coordinate plane here, I want to note where these critical values occur. These are kind of like invisible barriers that each piece of the piecewise function will not pass. Up here we have -1, so I want to mark at -1 that I have one of these special numbers. I also have +1, so I want to mark that +1 is going to be special, and then I have +2. So I just am putting some vertical dotted lines there for my own reference. Again, they're not part of the graph itself. Now I can go ahead and start plotting some things. When I look at this first piece, any x that I choose will also become the y coordinate when I go to plot. I can choose any x that is strictly less than -1. So -2 and -3 will work. If I choose -2, the y value becomes -2 because the y value is mirroring whatever the x value is. It says x if x is less than -1. So the x that I choose becomes my x and y value. So at -2, I will have a point. And then if I do -3, at -3, I will also have a point. As I connect these points, moving back towards that barrier that I created, I'm going to stop at that barrier. And I need to decide, do I need an open point or a closed point? It's going to be open since the inequality is not underlined, meaning we did not include the point -1. So I'm going to indicate with an open circle there. So this is a line that is going down and to the left, and I'm going to put an arrow indicating that this is going to continue to go. There is no lower limit, it's just running out to -infinity. The next piece is trapped between -1 and 1. So these two barriers that I put here, the entire graph is trapped between there. These are both underlined, so my endpoints are going to be filled in because I'm including those endpoints, -1 and 1. For every x that I choose in this domain, the y value is going to be 3. So there's no special calculation we need to do there. I can choose 0, that's definitely between there. I can choose 1, I can choose -1, and I can choose any of the fractions in between. Everything is going to be 3 for the y value. So I'm filling in those endpoints. Those are solid. So I have kind of like a little bar right there. And then lastly, for this third piece, I can choose any x that is strictly larger than 2. I'm going to take that value and plug it in here. One value I can choose is 3, so I'm going to drop 3 into there. So I'll want 2 times 3 is 6, plus 1 is 7. That'll be my y coordinate. So when x is 3, y will be 7. Right? And then I will need a second number as well. This is a linear piece, so I need at least 2 numbers or 2 points to figure out where this thing is going. I can choose 4 as well. So I'm going to do 2 times 4 plus 1. 2 times 4 is 8, plus 1 is 9. So the next one up, I'm going to This will be an arrow moving up and to the right. And then as I come back to this barrier, this is not underlined, so this is going to be an open circle. All right, so now we have the plot of our function here. I have this piece that goes down and to the left, this little bar in the center, and this piece that goes up and to the right. Things that we typically like to discuss with functions is the domain and the range. The domain is almost told to us directly. It is comprised of these pieces here. I have every x value from negative infinity, there's no lower limit here, up through positive 1. I go from negative 1 here to negative 1 here, so this is kind of a continuous piece there of the domain. But then I have this jump from 1 to 2, so that's not a part of my domain, and then I will have everything from 2 up to positive infinity because there's no upper bound here. So the domain is going to be from negative infinity up to positive 1, and then from 2 to positive infinity. And I need to include 1 here. 1 is a part of that, but 2 is not. Okay, so this is our domain. And then our range has a couple of big gaps in it. There is a gap here that's not included in the range, and then there is a gap here that's not included in the range. If you would draw horizontal lines through those areas, you would not touch both the plot of the graph and the y-axis at the same time, so those are not included in the range. So we have, again, this one's going all the way down, this one goes all the way up. So we're going to start at the infinities. So we're going to start at negative infinity, and we're going to move up until we get to this location here. Negative 1 is an open circle. It's not included there. We then jump up here to 3, and we do include that. And then we jump again up here to this point, which is not included. And the y value here is 5. If you plug 2 into here, this would be 5. And then we go from 5 up to positive infinity. And so that is going to be our range. Hopefully this has helped you understand how you can plot a piecewise defined function, and also some of using that graph to understand what the domain and the range is for that. Cheerful calculations.